Now, do you think that, since all they're doing is times 2, times 2, times 2, that they are going to think that that's not exponential? Because where is the exponent to them?
So that's another question.
You know, they're going to see that, yes, it grew very fast, way better than this did, but they aren't
They don't
seeing
have the
anywhere. They're doing
equation.
times 2, times 2. They're not going to
Right.
think at all that it's
Well,
exponential.
prior to this, I mean, and we can make a point of it, of activating that prior knowledge and say, remember that times 2, times 2, times 2, that's the way we express exponential, 2 to a power, whatever it is we're multiplying over
We
and over
keep
again.
doing
So this is
product
the
of two.
equation.
Right, so that there is a little
Well,
connection there, so
So you're
they,
filling out a table, students, of y equals 2 to the x. Here's what it is when x is 1.
We could put it on our worksheet.
put the equation
On our
there.
worksheet, we could put the equation, well, we could put, when we did it, we could have 1, and then we have 1 times 2, which we could put in parentheses 2 to the first power. And then we could, because we're filling in a few, we said, right? Then 2 times 2, which is 2 to the second power, and then 4 times 2, or, you know, I mean, like, as we're filling it in, and we're showing that we're doing times 2, because we're gonna fill in a few, we can show them that it's to a power, in parentheses, just like we did on this, when we showed, rather than just writing 1/2, we wrote 1 over 2 to the first power.
Why not let them just fill it in? We start them off 1, 2, 4, 8. Once they've filled it all in, when we recap and discuss the whole thing and we decide, oh, well, we're gonna go with the doubling thing, maybe at that point is the point we say, well, 1 is 2 to the 0. 2 is 2 to the 1. You know, try to pull that out of them and let them see that this is really 2 to an exponent, that we
Right,
can
you
change
say,
it, why
well,
not let that
grew
come at
very
the end?
fast, so it makes us think that it's exponential, as we've seen. See if we can prove it. How can we prove that this would be an exponential equation, rather than just looking at all, you've got your values, it's like you've got the table filled in, but you just don't know what the function is.
I mean, like, what we want them to see when we look at when they compare the table of values, we want them to see that the exponential one got a whole lot bigger, a lot faster by the time we
Right.
get down to 3 on both of them. That was only a measly 15, but that's 125. What would happen on 4? And that they see the growth is huge, and then bring it back with this problem when they figured out the doubling table growing really fast. Is this exponential? I mean, I haven't given you an equation,
Right.
but can we, you know, is this the result of something to a power?
Right.
Some
Has
it
number to
pulled
a
out
power? What
that
is
to
that
the
number
right.
to a power? Does
Right.
anybody
So
recognize
rather
any of
than
these?
putting the equation there, so no
Yeah, because
equation.
that will confuse them.
That will confuse
Well, I
them,
think
because there is no equation.
You
that'll-
probably want them, I guess you really have to think about what you're saying is, do we want them thinking about whether this is exponential or not first, or whether you want them to tell them that it's exponential and want them to think about proving it. But if they recognize it, you think if they saw that growth, they'd say, this is probably the exponential one?
We want them to
You want them
recognize
to-
that exponential
you want
has
it to
enormous
see that.
growth.
So
We want
then-
them shocked by the growth, but then we want them to realize it's the
Same.
exponential that's the growth,
Right.
not just this one problem that happens
Mhm.
to be a doubling problem. Right, we want them to make the connection to the whole idea of exponential. So maybe just, we could bring it up after, while we talk about it, say, wow, are you surprised, you know, do you want to change your mind now of how much money you're gonna take? And then talk about it, did you know that this is an exponential problem, and show them how it is.
Yeah, at least we'll chew that over between now and the next time.
That's something to think about, how we're gonna do that.
I mean, I wonder if they'll even connect it.
Probably
Yeah.
not.
They might.
They might.
And
A
it
few
could be
of them
but I
might.
think-
mean to say it's exponential.
I say, what is this, you know, is either of these exponential, or what kind of, you know, what is this? What is this one? What are
goes so
these two?
fast, what do you
Originally,
think
I
it is?
had paired them as a linear, and the linear one now has turned into a y equals 1,000, really, which is,
Horizontal.
there's a horizontal line. It's linear, but it's horizontal.
Yeah.
The other one is exponential,
So maybe
so.
we shouldn't even talk about that one.
Well, you can say it
might.
grows at a constant rate.
Right.
You know, it's a constant
Grows at
rate, so if you were,
1,000%,
right,
The sum grows at a constant rate.
right.
Do we want to go on and extend it to getting the equation, 2 to the x?
Well, you know, if you have if you're able to show them on the monitor maybe they don't have to actually, you can help them through coming up with the two equations so that you can kind of bring the whole process together, because the three ideas, the graph, the table, and the function, to end it by saying, so if we were to write an equation for these so you could see a graph, and then help them get the equation that it is to the second power, and then show them, you can graph it and say, look at the difference here. This one is linear and at constant rate. Look how, if this were the sum each day, look how that grew and this grew, just so they can actually see it and understand why it isn't just
I
2
think
times
there's-
X.
I think there's great value in that, when it's all done, at the very least, if we graph on an appropriate scaled window for them to see y equals 2 to the x and y equals 1,000x, which is just displaying for them the different amounts on an individual day, and them see that gap getting
Right.
absolutely enormous.
Right.
You know, just to recap the whole thing, yeah.
We'll tie them all together, and that's
Right,
really
'cause
what we're trying to do.
You're ending it in the same way, the three
Yeah.
different,
And then
three
the bell
different
rings and we go
ideas.
home and everyone's happy, right?
No homework, huh? We haven't talked about
And they
that.
all go home
I
and say, I'd
know.
like to change my allowance situation. Would you mind doubling it every day? I'll only take a dime.
I'll start with a penny, just a penny, Mom. Penny and double it.
taken. That's right.
I would have been taken at first. I would have. If you said it to me, $1,000 or double each day, starting with a penny, $1, I would have, I think, said 1,000. I mean, I would have thought about it because I would have thought, why are
As
they
a
asking me
trick.
that?
right.
You know, but,
Yeah, but turn the tables now. They have a student going home and say, you know, I've been thinking.
right, if my child
Money's
is-
tight. Money's tight. Cut that allowance
We're going to
down.
revert to
Let's
a
cut it
daily
down.
allowance. We'll start with a
Just
penny.
double it, and just double it each
Yeah.
day.
Good thing.
Can you see the phones ringing?
And that's when you jump up and say, they did it, they got it.
Yes, exactly.
So if we end that way, at least then we're touching on both our goals at the end of the lesson. They see the drastic increase of exponential, and then they see, okay, here's our table, you know, how much we've gone up each day. Here's our graph, now they can see it, you know, I mean the line and the exponential graph. And then this is the equation, and now they see all three at the end, and it's all tied in together.